Hi everybody, welcome to a new video, and this video is part of my Starting with Jitter series, and we are going to start now with 3D graphics, so with OpenGL in Max. That's because I'm super passionate about 3D graphics, and we can anyway incorporate 2D graphics inside 3D graphics, so I don't see why we should not directly start with OpenGL. So if you don't know anything about like how to create 3D shapes inside Max, this will be hopefully a video that can help you to do that and maybe connect them with some different inputs. This kind of stuff we will see in this video. So let's start. First of all, the first object we need is a Jitter world object. This is kind of our three-dimensional world. And the Jitter world object has only one argument, which is the name of our world, or our OpenGL context under the hood. So we have to choose a name for the Jitter world. Can be whatever name, it doesn't matter, we can take it out of our head. I will call it, without much fantasy, I will call it my world. Okay, and then this is basically it. So let's create it. When we create it, we can see that this big black window appears. And we can resize it. This is where our 3D graphics are going to be rendered, so to be drawn. For the moment, there is nothing on these windows, so let's activate our Jitter world. We can activate this with a toggle. So by pressing T, we create a new object called toggle. And this object outputs a 1 or a 0, which we can use to activate the Jitter world. So now the Jitter world is working and is rendering on the window. You can see that the color changed from black to a slightly grayish color. Okay, as you can see, every time I click on my patch, the window, the Jitter window, this is our OpenGL window, goes behind my patch, which can be actually quite annoying. In order to prevent this from happening, we have to give an attribute to the Jitter world. And you will get used to use attributes a lot when working with Jitter, especially with 3D graphic stuff, because attributes are really important here. So the attribute that we want to use is floating, and we give it a value of 1. So this is the name of the attribute. This at character means that this is an attribute. This is the name of the attribute, and this is the value that we assign to the attribute. Okay. So now the window will never go behind our max patch anymore. So I activate it anyway. And we can also choose some starting size for our window. And we can do that by using the size argument. So I will make a size of 320 by 240, which gives us an aspect ratio of 4:3. And we have this little, the window is now a bit smaller. As you can see, every time I recreate the world, it starts by being unactivated, so it starts by being off. And this way, if we want that it starts automatically on, we can give it the enable attribute. So we say enable 1, and the world is automatically on, even if I don't click on the toggle. Then when I click the toggle again, it will go off, of course. Okay, so let's start by changing the background, because this is our background color. By the moment is this boring gray, so let's actually change it. So let's go into the attributes and choose erase color, and let's say, for example, that I want kind of a greenish color. I will do something like that. This is kind of a water green. So when working with 3D graphics, the colors are in this order. So 3D graphics, color order, it's equal to red, green, blue, and alpha. So when working with Jitter and with 2D graphics, the color order, so when working with images and videos, the color order is, what did I write? Alpha, red, green, and blue. But when working with 3D graphics, the colors are actually the alpha is on the last spot. And when working with the images and videos, the alpha is on the first spot. A bit confusing, but you will get soon used to it as soon as you start working with Jitter a bit more extensively. So perfect, we have a background color for our world, because basically 0.1 is going to be the color for the red, 0.8 the color for the green, 0.6 the color for the blue, and 1 is the alpha value, since we don't the alpha value for the moment we leave at 1, and we will see probably in the future how we can use it to create some interesting effects. So let's now create our first three-dimensional shape. So let's start now by creating our first three-dimensional shape. So the first shape we are going to create, it's contained inside this object, Ggl grid shape. And as you can see, it has the prefix jit, which is common to all jitter objects. And then it has another prefix, which is gl, which is common to all the 3D graphical objects. And then grid shape is the name of the object. Now, all the 3D graphical objects, so the ones that have this gl, are linked to our world through the name of the world. So they get an argument, which is the name of the our OpenGL context, which is the name of that we gave as the first argument to the world. So I will type the same name as the only argument of Ggl grid shape. Now, as you can see, even if I don't type the name, the shape gets rendered correctly, because it kind of knows that we have only one world in our patch, and it's going to draw, of course, to this one. But it could be that we have multiple worlds, and we want to draw some shapes to one world, some shapes to another world. So it's always good practice to give to our shape the name of the world. So here we have our first three-dimensional shape. It's actually a sphere, even if it doesn't really look like one. And this means that by default the Ggl grid shape gives us a sphere object. It actually can give us also some other objects, we will see this in a second, but by default it's a sphere. Now, it doesn't really look like a sphere because we don't have any lighting activated for this object, because what gives us the kind of the shape of an object is how the light interacts with the object. So in order to activate the light for this object, we have to give it an attribute, which is lighting enable, and we set it to 1. So boom, we set it to 1, and we can see that this looks kind of more like a sphere. If we want to go full screen, it's really simple. I just throw this on the side. To go full screen, just press escape, so the escape key. And this is a function that is integrated inside JIT world. So if I click on the window and I press escape, then we can go full screen. Alright, so going back to our sphere. It's actually kind of big. It's either too big or too close to our virtual camera. Because in this world, in our virtual world, there is actually a virtual camera that kind of shoots the scene. And we can imagine it as to be our eye. So it's even too close to the camera, or it's too big. So what we can do is to actually scale it down. And the scale range is goes from 0, which means the shape will disappear, and 1 is kind of the normal shape. So if you go above 1, it will kind of get bigger and bigger. So the normal range is in between 0 and 1. So if we say scale 0.5, the shape will just get smaller. Now let me introduce you a new object, which is super cool. It's called Ggl Handle. And if we connect this to the grid shape, we can then go in our window and manipulate the shape with our mouse. So super cool. Let me actually write down the commands. So if we click on the shape and drag, we can rotate. Then if we press Alt and drag, we can move on the Z axis. So Alt plus drag. It means move back and forth. And then if we press Ctrl or Command for Mac and drag, we can move on the XY plane. So Ctrl plus drag equal move on the XY plane. So basically parallel to the camera plane. If we want to bring our shape back to its original position, we just say reset. So we create a message box, we write inside the reset, and the shape will go on its original position. There is a very cool attribute that we can give to Jitter, which is auto rotate. So we say auto rotate 1, click on the shape and give it kind of a little spin, and it will start to spin on its own. So pretty cool. Now, of course, we can choose a different color for our shape. We can do the same way we did for the Jitter. We can kind of hard code it inside the shape. So let's say that I want to have a red shape. I will write 1 for the red, 0 for the green, 0 for the blue, 1 for the alpha. And here I have my red shape. As you can see, it's still influenced by the light, which means the part that are in the shadow will be represented as completely black. Now, there is another thing to talk about it here, which is this sphere doesn't look so polished. It kind of looks like it's made from these several quadrilaters. These are actually called polygons. So in order to make it appear more smooth, there is an attribute that we can give to the sphere, which is move shading, and we set it to 1. Now, as you can see, the shape looks almost exactly like a proper sphere. This is because the light is getting interpolated in between all the vertices of the sphere. But this we will anyway see a bit onward in this little course. There is one more thing to make it appear a bit more spherical. As you can see, kind of the borders of the sphere are still kind of just composed by lines. And this is because in a computer we cannot have kind of a perfect sphere, because it's just an approximation of single points. So in order to have like a better approximation, we have to increase the dimension of this grid shape. So the grid shape has a dimension attribute, which by default is 20 by 20, is like a grid. So it means that it's kind of a two-dimensional matrix. So it is actually a two-dimensional matrix. But for the moment we are not going to see exactly how this matrix is composed. We are just going to make these dimensions bigger. So we can go up, for example, to 200 by 200. This means that we will have an amount of 40,000 vertices. So we have now 40,000 vertices. We can actually also take a look at those vertices by using the attribute poly mode, which means polygon mode. So how the polygons are going to be drawn. Are they going to be drawn as filled polygons, like this is the case, or are they going to be drawn as a wireframe? Like if we set the attribute to 1, 1, we will have a wireframe drawing. Otherwise, we can set them to be drawn as single vertices. So with 2, 2, we draw them as single vertices. We can actually create a message to modify this attribute. And this attribute has two parameters, two variables, because one is for the front face and the other is for the back face. But for most of cases, you just want to keep the same value to both those parameters. So let's create a radio group object, set the size to 3, and this will give us three numbers. So this will give us the numbers 0, 1, and 2, which we can use to modify the attribute. Alright, so this is kind of it for the grid shape for the moment. Now I would like to bring back the grid shape. Oh, and let's actually default the poly mode to 0, 0. I would like to bring back the grid shape to scale 1. Now, as you can see, I give only one parameter to the scale attribute, but actually I can give it 3 numbers, and every one of these numbers makes a scale in a different axis. So the axes are scale X, Y, and Z. Now, if I change one of the axes differently from the others, you will see that the shape kind of gets stretched in the axis that has the bigger value. Now, the thing is that when I use only one single number, it will consider this single number to be valid for all the x's and y. But let's for the moment bring it back to 1. Now we say that this shape is too close to our virtual camera, which means that we actually can move our camera. Instead of making the shape smaller, we can actually move our camera out and bring it a bit farther from the shape. So in order to do that, we have to create an object called Ggl camera. Give it also the name of my world to kind of link it to our current context. And then we have to say the position of this camera, we have to kind of change it. So the position is working like the scale, and usually like everything in OpenGL, the order is always x, y, and z. So position, x, y, and z. So if we want to make the camera a bit farther, we want to change actually the z position of the camera. So let me get 1 second an image. This is how the axes are oriented in OpenGL. So if we want to move this is where we are. So the camera, even if it's a bit ugly with these eyes, but this is where the camera is. And if we move in the positive direction in the z-axis, it means that we're going farther from the center of the world. If we move positive on the x-axis, it means we're going right, negative we are going left. Positive on the y, we are going up, negative on the y, we are going down. So if we want to move on farther away from the shape, we have to give it a positive number to the camera. By default, the value is 2, so we can give it something like 4. Okay, now our shape is still scaled to 1, but we actually have moved the camera away from the shape. Alright, so everything looks good. Let's actually create like a floor for our little scene here. So I will create another grid shape, so Ggl grid shape, my world. I would say lighting enable, smooth shading, and then I will give it a different color, like maybe blue, so 0, 0, 1, so 0 for the red, 0 for the green, 1 for the blue, 1 for the alpha. And this by default is going to be a sphere, so I have to say shape, and then give it the shape that I want, which is plane in this case. Now, how do you know how many shapes there are inside the grid shape objects? Well, you can just take a look at the shape attribute. So you can do it in this way. You create an attribute object, attribute inspector. This object is called attribute. Click on the left side of the object, and you all the attributes of this object will appear. Then you go into shape, and you can see here on the right part of the object, you can see all the shape that this object can assume. So, for a moment we are going to get the plane one. Another way to get all the attributes of this object is with the patch unlocked, to click on the input of the object, and you can get all the attributes and the message. And when you click on the attribute you want, a new attribute object will be automatically created, and then you can inspect the attribute or just choose another one. Okay, so now we have a plane, but as you can see, is kind of just cutting in half our shape. So what we have to do is actually to rotate it in order to make it flat. So to do that, we just use the attribute rotate x, y, z, and we want to rotate it on the x-axis of 90 degrees. So the y-axis 0, z-axis 0. Now it just disappeared. That's because it's just parallel to our view. So since it doesn't really have a thickness, it just kind of disappears. So let's actually move it a bit below by changing its position to 0, -1 on the y, and 0 on the z. And now we can see that our shape is kind of resting on the floor. We can make it a bit bigger to make it a bit more floor-like. For example, scale 5. Now we have kind of a little scene going on. Let's try to move our camera to kind of move around in the scene. So we can do that by using the pack object without the C. So this means that every time we change an input, we send something in the input of this object, the whole list is going to be output. So we can then connect like three floating number boxes to change the position of the camera. Can change, for example, the X position. Oh, and this should be actually 4. So let's actually hard code 4 inside the pack object. We can change the Y position of the camera, we can change the X position, and we can change the Z position. If we want to kind of reset the position of the camera, we can create a message with just these 3 numbers connected to the second input of position, and this will kind of reset it to our chosen position. So another interesting way to move the camera, it's actually to attach it to a git.anim.drive object with the attribute UI listen set to 1, which means that it will listen to our keyboard. If we attach this to the Ggl camera, it means that we can actually move around by pressing our W, A, S, D, Q, and Z keys. So when we press those keys in our keyboard, so first we have to click on the window. Then we can start to press those keys, and we can kind of navigate inside our world. With the mouse, we can actually also rotate the camera view. Okay. So if we want to go back, once we use the Git anim drive, this will just get us back to the original position, but the rotation, as you can see, is still changed. So we have to give it the message anim reset both to the Git anim drive and the camera. So we click on Git anim reset, and we will be sent back to 0. And then we actually have to click back here on this message. So the patch is getting already a bit crowdy, and I think I will leave this video at this, because we already introduced kind of a lot of objects, a lot of stuff. Oh, there is also a slider for some reason. I will stop here, and in the next video we're going to see some more interesting stuff we can do with 3D shapes, how we can change their appearance, how we can get a better lighting, and yeah, this kind of stuff. And we are going on and on in our study of the three-dimensional world that we can have inside Max MSP. Maybe we will create also a little video game. Who knows? This is always kind of my what I like to do. Okay, so thank you for following. You can check out my Patreon page if you want to contribute, or if you want to download some patches that I share only with my patrons, you can check my Patreon page. Anyway, thank you for following the video, and see you in the next one. Ciao, guys.